parameter versus statistic. Parameter is associated with population. So parameter, they are used to describe an aspect of population. While on the other hand, statistic is associated with sample. So statistic is used to describe an aspect of a sample which is taken from the population. So parameter, it's related with population. Statistic, it is related with sample. For example, you have your population mean, which is denoted by this symbol, and then you have your sample mean denoted by this symbol. You have your population standard deviation. You have your sample standard deviation. You have your population proportion. You have your sample proportion. You have your population size and you have your sample size. For example, the average weight of all the people in a town is 63.4 kg. Basically, the mean weight of all the people in the town is 63.4 kg. This right here is your parameter because it's associated with the whole population. On the other hand, the average weight of 20 people sampled from a town is 61 kg. So basically, the mean weight of the sample is 61 kg. This right here, on the other hand, is your statistic because it only deals with a small sample taken from the population. A certain surveyor wants to study the weight of a population. The size of the population, capital N, is equals to 100,000 people. So there are a total of 100,000 people. And it is obviously going to take a lot of time to survey 100,000 people and to find out the weights of individual people of that population. So what the surveyor does instead is that he takes a small piece of this population, which we call a sample, and the size of the sample is 100. So he selects 100 individual out of 100,000 individual, and these 100 individual are going to represent these 100,000 individuals in the study of the surveyor. The surveyor finds the mean weight of the sample to be 63.4 kg. Now 63.4 kg, which is the mean weight of the sample, is what is representing the mean weight of the population according to the surveyor. From his study, the mean weight of the sample is 63.4 kg, and this mean weight is going to represent the mean weight of the population. But in reality, the mean weight of the population is 61 kg. So you can see that the mean weight of the sample that the surveyor calculated is different than the mean weight of the population. That means the sample is not 100% accurate. The sample is not 100% representative of the population. This is what we call a sample error. And while studying a sample, there is always a sampling error that exists. And that is why while mentioning any statistic that is representing a population, instead of directly mentioning the statistic, we use something called a confidence interval. So what exactly is a confidence interval? This is confidence interval. See, the population studied the sample because it was much difficult to study the population. So whatever result comes from the sample, he's going to use that result to represent the population. After his study, he finds that the mean weight is 63.4 kg. So now he's going to say that the mean weight of the population is also 63.4 kg because sample is representing the population. So this is also representing the population. So according to him, the mean weight of population is 63.4 kg. However, since the real mean weight of the population is not equal to the mean weight of the sample due to some sampling error, the surveyor can't say something like this. The surveyor can't say that the mean weight of the population is 63.4 kg. Or basically, the surveyor can't say that the parameter representing the population is equal to the statistic that he has calculated from the sample. He is calculating statistic and he is using this statistic to represent the parameter of the population. But due to sampling error, the statistic is never equal to parameter. So what the surveyor does instead is that he uses an interval, and the surveyor simply says that the mean weight of the population, which is the parameter, probably lies within this particular interval. How this interval is calculated, that I'm gonna tell later, but hear me out. This interval right here, which provides a confidence for the existence of the parameter, is what we call confidence interval. So what is confidence interval? Confidence interval is an interval which provides a probability of having the parameter. It gives a probability that the parameter is within that. Again, one last time. The surveyor calculated the mean weight of the sample. Instead of saying that the mean weight of the population is the same as the mean weight of the sample, the surveyor says that the mean weight of the population, lies within a range where the mean weight of the sample is here and the mean weight of the population is probably here or here, somewhere within this interval. And this interval that probably contains the parameter or the mean weight of the population is what we call confidence interval. For example, for our particular example, here's the confidence interval, and the mean weight of the sample is 63.4 kg, which is present right here, and the mean weight of the population is 61 kg, which is present right here. So there's a chance that the parameter is present within this interval. Okay, the size of the confidence interval is dependent on two main things. So there are two things that affect the size of the population. First is the variability, and second is the sample size. See, the less variation there is, within the population, or higher homogeneity is there, or more homogeneous the population, the smaller the confidence interval. The smaller the confidence interval, that means there is higher confidence of existence of what? Higher confidence of existence of the parameter within that interval. So we can say with more confidence that the parameter is present within this much. Next is greater the sample size, also smaller the confidence interval. Let me explain it to you. See, first thing is, the more homogeneous the population is, more representative the sample is going to be. More representative the sample is going to be, less sampling error we are going to have. Similarly, larger is the sample size, less is the sampling error. Okay, got it? So first thing was, if the population is homogeneous, the sample that we get from that population is going to be more representative of the population, because there is less variety of people. The more likely the people are the same as each other, the sample is going to also contain the same type of people. And since there are going to be same type of people, the sample is going to be more representative of the population, then there is going to be less sample error. Okay, similarly, the greater the sample size, the more population representation is within the sample. More representation of population is within the sample, less will be the sample error. Okay, so that's how the confidence interval is affected. One by variability and other by sample size. Now here's the mathematical formula. Mathematically, your class interval is equals to the sample mean plus minus the Z score times the standard error, or you can just write it as the class interval is equals to the sample mean plus minus the Z score times sigma by root under n, where sigma is the standard deviation of the population and n is the sample size. Ci is your class interval. It's your class interval. This is the mean of the sample. This is Z score. This is standard deviation of population, and this is the sample size. So the interval will look something like this. So here's a class interval. Within the class interval lies the mean of the sample. This right here is the lower limit of class interval, and this is the upper limit of class interval. The formula for class interval is equals to mean plus minus Z score times this standard error. So the upper limit is going to be equal to mean plus Z score times standard error, and the lower limit is going to be equal to mean minus Z score times standard error. The next terminology is confidence level. The confidence level basically tells you how confident the surveyor is that the parameter of the population lies within the confidence interval. So basically, confidence level tells the level of confidence of the surveyor. That is how confidently the surveyor can say that the parameter is within the confidence interval. How confidently can the surveyor say that yes, the mean weight of the population is present in between this upper lower limit and this upper limit? How confident is the surveyor? In other words, it tells the percentage probability that the true population parameter is in the confidence interval. Basically, within this confidence interval, what's the percentage probability? What's the probability that the mean weight of the population, is present somewhere in this interval, Mostly used confidence level are 90%, 95%, and 99%. For example, if a surveyor says that the surveyor is 90% confident, then the confidence level is 90%. If the surveyor says that his confidence level is 90%, it means that he is 90% confident, or there is a 90% chance that the true population parameter, that is the true mean weight of the population, is present within the confidence interval. So confidence level basically just tells that the surveyor is confident enough by this much percent to say that the parameter of the population is present within the confidence interval that he has generated with the help of the statistic that he calculated from the sample. I want you to break the line that I just said right now. Okay, so mathematically, the confidence level is equals to 1 minus alpha, where alpha is the threshold limit or the maximum limit of type 1 error. Threshold of type 1 error. So the question is, when does the confidence of the surveyor increase? The confidence of the surveyor increase when alpha decreases. So when alpha decreases, the confidence level increases. Obviously, when the chance of error, this is the chance of type 1 error. When the chance of type 1 error increases, there is less probability, there is less probability of sample error happening. So obviously, the confidence of the surveyor is going to increase to say that yes, this parameter is present within this interval that I have said. Makes sense. For significant result, let me write down. For significant result, this is important to know. That is to finally say that what I have came up with is significant enough for significant result. Alpha needs to be less than or equal to 5% or 0.05. And if you put this formula within this particular, if you put this value within this formula, you'll find that the confidence level needs to be more than or equals to 0.95 or 95%. Let me write down 0.95 or 95%. So this was for type 1 error. So obviously when type 1 error decreases, the confidence of the surveyor increases. Now he is more confident, and with more confidence he can say that yes, the parameter of the population is within this interval that I have generated with the help of my statistic. There is another terminology as well called power. And power deals with type 2 error, which is equals to 1 minus beta. What is beta? Beta is the probability of, it's the probability of type 2 error. So obviously, less the probability of type 2 error, more will be the power. Another important thing that you need to know, values of Z or Z score at different confidence level. That is, when the surveyor is 90% confident, what is the Z score at that point? So there are 3 different levels of confidence for which you need to know the values of Z. First is 90% of confidence level, second is 95% of confidence level, and third is 99% of confidence level. For each, the Z value, the Z value, the Z value, the Z value. Okay. So Z value for 90% of confidence level is 1.64. Z value for 95% of confidence level is 1.96, and the Z value for 99% of confidence level is 2.58. Okay, now that you have collected all the information in your mind, I hope you can do this next numerical that I am going to give you right now. The numerical is, so the size of the population size or capital N is equals to 1000. The sample size or small n is 100. So there's a surveyor. He wanted to study the weight of the population. The size of the population is 1000. So he instead takes a small sample of the population. The sample size is 100. Okay. The standard deviation of weight of population sigma equals to 2 kg, and the surveyor calculates the mean weight of sample to be 70 kg. Now what the surveyor wants to do is that he wants to establish a confidence interval, basically an interval within which the actual mean of the population of the mean of the weight of the population lies. So he wants to create that confidence level. Confidence. He wants to create that confidence interval. And the amount of confidence he wants the interval to say with, basically the confidence level the confidence level is 90%. I'm going to tell you the steps and you are going to calculate the answer on your own. So first, simple, you want confidence interval, so you are going to use the formula. That is the mean of the sample plus minus Z score into standard deviation. The range is going to be between the lower limit to the upper limit. As for the Z score, you are going to use the Z table to find the Z score for the confidence level. However, I've already told you to mock up Z score for 3 different confidence level. For this confidence level, you need to know the Z score by heart. And the Z score for 90% of confidence level is, come on, 1.64. So put the values in and you will find your confidence interval. After you have found your confidence interval, you can write the conclusion as there is a 90% chance that the true mean weight of the population is in between this much kg to this much kg. This is going to give you answer in kg, which is going to be the lower limit. This is going to give you the answer in kg. This is going to be the upper limit. Sayonara.